Hi, everybody, and welcome back. We had a special request to go through an algebraic example of how to solve the allocation problem, finding the prices and quantities under trade in the presence of a per unit tax. So this is just sort of to continue from the last video, which talked about the basics of taxes in terms of the equity and efficiency implications. We're going to extend that analysis now to consider a specific algebraic example. Okay, so important thing to recall, okay, from the last video is that it didn't really matter who we forced to pay the tax, okay, whether or not we made the buyer physically pay it at the counter or if we made the seller physically pay the tax. The resulting allocation did not change in that the price that the buyers faced was the same in both cases. The price the sellers faced was the same in both cases. And the volume of trade was also the same in both cases. Okay, so we're not going to really worry about who specifically we're making pay the tax, since that doesn't matter. The key feature for us today in solving this problem algebraically is recognizing that the tax creates this wedge. Okay, the tax is creating a wedge in between the price the buyer is paying and the price that the seller is receiving. Hey, how is it possible that the buyer pays more than the seller receives? Well, the government is collecting the difference in the form of tax revenue per unit. All right, so we're going to look at a different numerical example. This numerical example here was drawn from the last video, and we're going to use a specific example with demand curve functions and supply curve functions. Okay, so we're going to consider an analytical example with a per unit tax. Okay, first piece of information we need is the demand curve. Okay, notice I've included a B subscript here so that we remember that the demand curve captures the price the buyers are willing to pay. Okay, similarly, we have a supply curve. And note that I've included an S subscript on the price, since the supply curve tells us the minimum price the sellers are willing to accept at any quantity. And we've actually solved this problem in class. And we started off with the case where there was no tax and looked at the market equilibrium, recognizing that in the market equilibrium, two things happen. The prices are both equal along the demand curves, and the quantity supplied and quantity demanded are also equal, implying no shortage or surplus. So if you set those prices equal to one another, you can solve for the equilibrium quantity of 50 units, plug that back into either the supply or the demand curve, and see that the equilibrium price in the market is also $50 in the market equilibrium with no other restrictions. However, if we were to impose a tax of $10 per unit, okay, then we should be able to observe some market phenomena consistent with the last set of videos, whereby the quantity of trade goes down since the tax makes things worse for both buyers and sellers. All right, so this is the basic algebraic setup. We have the demand curve, we have the supply curve. I can graph my demand and supply diagram, and I know now the size of the tax that we have to wedge in between that supply and demand curve diagram. Okay, so in order for us to compute the volume of trade, what we're really going to do is just describe the condition of the tax wedge. Okay, recognizing that what the tax does is it creates distance between the price the buyer pays and the price the seller receives. And what's that distance? Well, the government mandates that that distance has to be at least $10. If any buyer and seller negotiate those prices closer together than $10, that's illegal because the government can't capture the $10 tax on those units being traded. All right, so the condition that describes mathematically the tax wedge is the following. And it says the difference between what the price the buyer pays and the price the seller receives has to account for the $10 tax per unit. Okay, that is the wedge condition. Okay, in order to compute the volume of trade, all we're going to do next is substitute our expressions for the supply curve and the demand curve in for these two prices. Okay, so the tax is driving a wedge of $10 between these prices. And we're now going to substitute out for P's in terms of Q in order to solve for the volume of trade. Okay, so again, starting with the wedge, I have the price that the buyer is paying in blue, price the seller is receiving in green. And remember what the demand curve equation was for PB. It was PB equals 100 minus Q. So I can go ahead and substitute that demand curve equation in for the blue PB. And PS was just equal to Q along the supply curve. So when I make that substitution, the above equation becomes the following. Okay, so if I add the two Q's over to the right, subtract the 10, I result in 2Q equals 90. Dividing through by 2 yields the volume of trade under the tax, which is exactly 45 units. Okay, so the thing to notice now is that our result makes sense, hopefully from the intuition that's been developed. Okay, the unrestricted equilibrium quantity in the absence of the tax would have been 50 units. So it looks like the tax here is blocking 5 units of trade that would have been mutually beneficial, would have enhanced surplus. It would have increased the economic pie. All right, now, last element, we want to figure out the different prices. Okay, this is a weird situation. In the market equilibrium, the buyers and the sellers pay and receive the same price because there is no wedge. But now that there is a wedge, okay, despite the fact the quantity demanded and supplied are still the same in the volume of trade, okay, the prices are now different. So we know that the quantity of trade is 45 units. So if we plug that quantity back into the demand and supply curves respectively, then plugging that quantity into the demand curve will yield the buyer's price, and plugging that quantity into the supply curve will yield the seller's price. And so the buyers are paying $55 when 45 units are being traded, and that's in the presence of the tax. And if you were to just subtract 10 bucks from that, we know that the sellers have to be receiving 45. We can verify that by plugging Q into the supply curve. And the supply curve equation was P equals Q. So plugging in Q yields the result that the sellers are actually receiving 45 bucks. So note here that the difference between the prices paid and received does account for the exact size of this per unit tax. All right, so just to convince you that we've really fully solved the problem here. If we wanted to, we could think about things like consumer and producer surplus. We could calculate elasticities of supply and demand at these allocations, because at this point, okay, we've solved for the equilibrium price and quantity. So I can compute the consumer and producer surplus in equilibrium. And with a tax of $10, we were able to compute the resulting price that buyers pay. So we can now find the consumer surplus under the tax and the price that the sellers receive, and we could compute the producer surplus, that bottom triangle, under the tax. And we can also see the deadweight loss in this diagram as well. So once we've solved for the quantity of trade, the price the buyer pays, the price the seller receives, and we compare that to the equilibrium allocation, we're able to fully conduct our welfare analysis using surplus. Okay, note also in this case that the government is an agent in the market now. It is collecting a piece of economic pie, and we treat that revenue as a positive piece of pie. Okay, so I hope that answers the questions regarding an analytical example of implementing a tax in the competitive market model. Hope to see you next time. Hope you enjoyed. Have a good night.